Good day, ladies and gentlemen, and once again we're back together. All right, and this time we are looking at acids and bases, just one of those long questions, right? So if you haven't subscribed, please just do the right thing. Okay, so I'm looking at the Eastern Cape exam, and this is from the 2023 prelims, right? So I skipped the first part and just jumping into the second portion of the question. They say to us we've got a concentrated a concentrated sodium hydroxide solution is diluted with water of 1/10 of its original concentration. They say exactly 35 cubic centimeters of dilute sodium hydroxide solution is mixed with 25 cubic centimeters of hydrochloric acid solution. They say hydrochloric of concentration 0.1 mole per cubic decimeters. Right, they say to us we've got a neutralization reaction that occurs in the flask according to the balance reaction. Right, of course, some of the acid will neutralize with the base, right? But they say to us, calculate the initial number of moles of hydrochloric acid in the flask. Now, okay, so we know that we had a volume, or rather, a volume of 25 cubic centimeters and a concentration of 0.1. Okay, so that should be easy enough. And that's why I was saying, guys, when it comes to acids and bases, you can actually just pick up some marks here and there, right? So that's concentration, that's just purely stoichiometry, right? 0.1 multiplied by the volume. This is 25 cubic centimeters, but in this case, we need to just convert that to cubic decimeters, right? Okay, so that will give us 0.0025. That's the number of moles that we've got, okay? So of hydrochloric acid. And note, these are the initial moles. Okay, we'll come back to these a little bit later. Right, so the next question says to us, the pH of the final solution is 12. So now what does that mean? It means when you added the acid and the base together, some of it neutralized, but some of it remains unreacted. And what remains unreacted? In this case, it is the base, right? That's why we've got a pH of 12. So it tells us that sodium hydroxide must have been in excess. Okay, so for 7.2.2, we're going to say, right, they say calculate the concentration of the hydroxide ions, right, in the final solution. So we're going to say, right, now there are two ways of doing this. Okay, so we know that pH is minus the log of the hydronium ion concentration, right? Remember, if I want to find the hydronium ion concentration, this will simply be 10 to the minus pH. Okay, please keep that in mind. So this will be 10 minus 12. Okay, that's our concentration of the hydronium ions. But, so this is moles per cubic decimeters. Okay, but I know I'm not looking for H3O plus, I'm looking for OH minus. So what do I know? The ionization constant of water, okay, this is times OH minus, will give us 10 to the negative 14. We're assuming this occurs at, at 25 degrees, right? So note you've got that ionization constant there. Right, so now we're looking for OH minus. Our H3O plus is 10 to the 12. And we're looking for OH minus. It's 10 to the negative 14. And so we'll divide both sides by 10 to the minus 12. the laws of exponents there. So our concentration will be 10 to the minus 2, which is 0.01 moles per cubic decimeters, right? And so that's the concentration of hydroxide ions in the final mixture. Now, I want you guys to please note what would cause that concentration. It would be the excess moles of sodium hydroxide. It would be the moles that did not react, right? So as a result, now the next question says calculate the the concentrated sodium hydroxide, right? So we're looking for the concentration of the concentrated sodium hydroxide. Now remember they said to us it's a tenth. So let's find out what the concentration that actually reacted. And of course, to get the original concentration, it will be multiplied by 10 of that. But let's do that. Right, so firstly, we are aware that we've got concentration of the final solution, right? So for 7.2.3, let's find out the number of moles in excess, right? So the number of moles in excess would be concentration times volume, right? So this would be 0.01 times, now I want you guys to remember, right? What would be the total volume of the resulting mixture? So we've got 25 cubic centimeters that was mixed together with 35, right? So if we add those two together, they give us 60. So that means that this is 60 over 1,000, okay? So that will give us 0.06. So if we multiply those two, we should have 0, in fact, let's say 6 times 10 to the negative 4 moles. Now, these were the moles of sodium hydroxide that were in excess, of hydroxide ions actually, that were in excess. But because for every one sodium hydroxide you get one hydroxide, it means that it will be the same as the number of moles of sodium. So now what we're going to do is, so which number of moles are these? These are the excess ones that remained unreacted after the two underwent they neutralized each other. They reacted with each other, but some sodium hydroxide was left unreacted. So now I know when it comes to sodium hydroxide, remember we've got the initial moles, right? So we'll say, so it means that to get the number of moles initial, it will be equal to the number of moles that reacted plus the number of moles that are in excess. Okay, right. So in this case, we've got the initial moles. We found out that, so there we go. We found out, no, actually we've got the initial moles of hydrochloric acid. Okay, yeah, please, we shouldn't make a mistake of that. Now, let's first, in this case, I want you guys to please note, is it possible for us to find out the number of moles of sodium hydroxide that reacted? Okay, now remember, since we've got the acid that reacted, right? Remember, we've got this guy, and we're working towards that in terms of sodium hydroxide, right? So now, what I'm going to do, I'm going to say to myself, right, how many moles of acid reacted? Well, it's all of what we've got, right? But what's the ratio between sodium hydroxide and hydrochloric acid? It's 1:1, isn't it? So that means that if I wanted to get the number of moles, or you can say, right, for every one sodium hydroxide, we will get one hydrochloric acid. That's what the ratio says, right? So that means for how many moles will we get 0.00 0.25 of hydrochloric acid. All you do is cross multiply, ladies and gents, and you'll see that the number of moles of sodium hydroxide that reacted with that with that hydrochloric acid was also 0.0025 moles. Right, so I now have the number of moles that reacted, okay, and I've got the excess moles. So that means to get the initial, I will simply say number of moles that reacted plus the number of moles in excess, okay? So this would be the excess moles. And so we reacted 0.025 and we had 6 times 10 negative 4 in excess. Okay, so that gives us 0.0029. Okay, you can correct me there if I'm incorrect. So in this case, this is the initial moles of sodium hydroxide. Now remember, we're looking for the concentration. So we're going to say, right, so the concentration is number of moles divided by the volume. So if our initial moles was 0.0029, right, our volume of sodium hydroxide, okay, remember they added 35 cubic centimeters, right? So there it is there. So that's 35 divided by 1,000. Okay, so that's 0.035. Okay, so that's divided by 1,000. So we're going to say 0.0029 divided by 0.035, and that gives us 0.082. So our concentration is 0.083 actually moles per cubic decimeters, right? And so what happens in this case? Remember, they were looking for the concentrated amount, but what do we note? That the concentrated amount, or rather the dilute, which was this one, this is the dilute as base, right? It came from the original, and this is a 10th of the original, right? So which means, let's call this concentration dilute. Okay, dilute is equal to 1/10 times the concentration of the concentrated amount, right? So what I'm going to do is multiply it by 10 on this side, multiply it by 10 on that side. So that means that the concentration would now be, or rather, let's just write it as C. Okay, the original concentration will be 10 times this amount. Okay, so this will give me 0.83 moles per cubic decimeters. All right, so I hope you understood that, ladies and gents. You can rewind and play that as many times as possible. All right, so that is how the cookie crumbles. I hope that you enjoy that. Otherwise, ladies and gents, this would be the last video that I'm giving to you guys. Okay, all the best for your chemistry exam. I do hope that you do well. For more content, I mean, I've published during our prelims. Please just look out for the more content on that I published earlier. All right, on the other sections. Otherwise, from me for now, it's ciao for now. It's really been a pleasure being with you all year long. Goodbye.